So technically, what we did in 2.3 by graphing all of them is what the textbook was hoping to leave you for 2.4. It's 2.4 is going to be the same thing, just practicing getting your asymptotes and graphing it. But there was some weird graphs in 2.3. So if we didn't actually graph them, you wouldn't have an experience of like that one that had the intercept on the asymptote at 4. That one was kind of weird. But we're going to, and each of these also provide a little bit of, oh, that's a little bit different. Because this one like has an algebraic trick in it. Oh, see if you can catch what's going to happen. We're going to factor first. So I'm going to have x and minus 4 and minus 1. And normally I would write 1 minus x on the bottom. But they want you to notice, they want you to be like, hey, wait a second. Can you cancel out 1 minus x with x minus 1? Are they identical?
No.
No.
You can't change it, but you can change it by applying the negative.
You can take a 1 minus x and pull out a negative, which would make the x positive and the 1 negative. And you have to do that in this situation because our non-permissible value, which is x can't equal 1, is not going to be a vertical asymptote. But you might think it is if you didn't recognize this. So it's going to cancel out and it's going to be a hole. And that hole is going to be at 1 comma something. And how do we find it? Well, we look at the equation. And we're left with an x minus 4 in our numerator. And what do I do in my denominator? Do I just do this? Because that's all that's left, was like the dash is the only thing that's left. It's a negative 1, yes. Now, this, in this form, I would say you should work with that negative. If I divide this by negative 1, do you see that the x would become negative x? And the minus 4 would become plus 4? And this is nice because this is in y equals mx plus b form. It's a straight line. And in our steps, sometimes this is supposed to be an easier type of question, but sometimes people overcomplicate it because they try to do too much. This does not have an oblique asymptote. Because once you have a hole, right, this green note, if there's a hole, you graph the simplified equation and add the hole. The simplified equation is just a line. We don't have to do anything. It's not even a rational function anymore. You just have to go back to grade 10 and graph that line. How do I graph a line? Well, I mean, you can, I actually like it if when you're graphing your line, you add your x-intercept and y-intercept. It's not hard. The y-intercept obviously is 4, a slope of negative 1, down 1, over 1, and as we go, you would get your x-intercept at 4, y-intercept at 4. How do we find the coordinates of our hole? Well, we plug 1 into the line and say, if 1 is a non-permissible value, somewhere along where x is 1, it's not allowed. Negative 1 plus 4 is 3. So I can go to 1 comma 3 and put an open circle. And there is our graph. So just because the degree is, right, careful, just because the degree is bigger in your numerator to start with, does not necessarily mean there's going to be an oblique asymptote. And in this situation, there isn't because there was a hole. And whenever there's a hole, you graph the simplified version. In fact, any of these previous graphs that we did, we could add holes to them. We could add as many holes as we want. Just have x plus 2 on top, x plus 2 on the bottom, cancel them out. That adds a hole to whatever graph you want. We could draw parabolas with holes in them. Take your regular parabola, right? You know how to graph x squared plus 4. Then multiply it by x plus 1 and divide by x plus 1. You add a hole to your parabola. Okay, so questions for this one are... Number 3.
Questions.
Question, well, I'm sure that 3 has A, B, C, D, E, F, and G or something terrible like that, right?
We didn't put domain range.
No, I'm purposely trying to be lazy and forget domain and range. But you want the domain and range, we can do that. Domain, easiest way to write domain is just say x cannot equal 1. And the range, the easiest way to write the range, y cannot equal, it has everything except for